Hi, class. Here are some suggestions or comments about our Unit 4 test that we just took on chemical reactions from the first test. So maybe this can help you do a little bit better on the second one. In no particular order, if we look at a reaction which is very simple, basically just dissolving salt into a couple of ions, we've still got sodium and chloride, just the ions are separated here. So this is what our notes, and we described as a little bit of a gray area between a physical and a chemical change. Not quite as clear as if you just maybe rip a piece of paper, but not at all like this one, where we've got carbon dioxide and carbon and oxygen, separate compounds here. So definitely a chemical change. Maybe a little bit of an in-between or the gray area there. Some people wrote some things down with nitrate and maybe even potassium ions that are like doing things. And the one solubility rule that we needed to know is that one there, that sodium, potassium, ammonium, and nitrates are all soluble in water. So if they're soluble in water, then they're not going to form precipitates or basically do other things in the reaction. So you do need to know that, and I can tell some people didn't know that one. General thing for a mole, that's very light. I'm sorry if that didn't turn out so well. A mole fraction means the number of moles out of the total number of moles. So if you want to get a mole fraction, if there's 1 mole of something, but out of 3 moles altogether, that's 1/3. That was one of the free response problems where it was suggested that maybe use one of these charts like we used in class. You don't have to do it that way, but I think it's nice and simple and easier for you. That's where you want to look at how much do you start off with, how much of it goes away or changes, and how much are we left with. When you know how much you're left with, you can answer the questions like the mole fraction. All your mole fractions should add up to 1, because that's just 100% of the stuff. Here's a reaction which on purpose is a little bit incomplete here. We've got chlorine gas and potassium iodide, and it's going to turn into iodine gas and some chlorine and some potassium ions. Again, we know this potassium isn't going to go together with this other stuff because we know potassium's soluble. But something maybe isn't quite right here. Looks like we've got 2 chlorines there, a couple of potassiums there. I think we might indeed need to balance it. If we separate this into halves, we will also see the electrons. They have to balance too. The whole point of this kind of reaction is that it's a redox reaction, an oxidation reduction. It's not just one of them, it's both of them. You got to have both. That's why the electrons cancel out. So for a redox equation or reaction, you've got both of them. You've got the reduction half where we are getting something, an element, more negative. It's gaining electrons. Remember GER? And something else, a different element, is becoming more positive. It's losing electrons. Remember Leo or oil rig, if you prefer. So most of the reactions that we learned about were kind of classified as a variety of that. That could be that halogen displacement, the hydrogen displacement, the acid, the metal activity series. All those are a type of that. The only thing that would not be an example of that is that the oxidation numbers for everything in a reaction, they all stay the same. They still might move around, the elements, but the oxidation numbers don't change. Then it's not one of those. So yeah, make sure you know pretty much all of that stuff for our second version, or our second time around. Think about what you know that you knew or you didn't. Keep this stuff in mind. Take a look at the notes like usual, practice problems we did, and you might have noticed, and I did say, that some of our equations, our reactions that we're using, come right from our worksheet that we did in class. I think it was section 4.9, the first part, the first worksheet. So study a little bit more, do a good job, and hopefully everybody will improve their grade.